today I will bring, let's say, different practical use cases on digital solutions, in this case also for the agro sector, and also technologies that we're being developing here also in Portugal with different partners, but also across different, let's say, with different partnerships from European countries and so on. So as we were talking also this morning, and in particular in these also last, let's say, conferences. So we know that we need to increase, let's say, the agriculture production because even the population is increasing, but also we need to take care in the way that we product currently. So it's now we have consumers more exigent, let's say, and so we need to increase this agriculture in the way that we can maximize also the yield by reducing the energy, but the mobile getting this real-time information that we get from the field to take also actions in the current moment, and by for sure doing across sustainable development goals. And so to implement in the sustainable system for the agriculture, we need for sure to implement what we call the agriculture 4.0 in the way that we can valorize these products, not only for the farmer or the producer, but also for the consumer, that we are also more exigent and mobile to produce more products by using the less resources. And when we say these less resources, we're talking about the water, the soil, and also reducing this AG inputs application through a more efficient and selective approach in then application. So what we want is also to minimize these environmental approaches or environmental costs and increase this agriculture in the sustainable way. It's true when we talk about the water availability, there's a lot of models already and the concerns and awareness whole days, and this is a fact, this is not a reality. So it's predicted that the water content available all around the world is tended to decrease, and we need to take clear actions on that. How can we do it? As I said before, through the implementation of Agriculture 4.0, but how? So let's say through a very implementation through a field monitoring system in the way that we can collect what we call the crop data monitoring to promote real actions in the real-time actions. So we can have this field monitoring, and this is not only for the water content, will be also for the weather stations, the temperatures, the soil, the age inputs, and so on. And what we need is to get this connectivity into the data analysis, and then to perform what we call the decision systems in the way that through these cutting edge solutions, we can get the application and the real-time monitoring systems to predict, but also to act on time. No, it's okay. And for this here in Portugal, so SFCOLAB, we are an association targeting different services for digitalization of the agriculture, the different also projects and research and development through the application or targeting applied research for this field. So we are driven by sustainable resources management, and what we want is to transfer the technology, but also the scientific knowledge from what we call the academia into the farmers and also to the end users. And so one of the practical use cases that I'm going to present is an edge solution that we have called a SOFIS, so a smart orchard ferti-irrigation system, in what we call that is customized solutions. So these are modular sensors that are customized and can from one side measure what we call the soil, but also the plant ecosystems in a way that we can then, through artificial intelligent, so we can get what we call the insights or the metrics to predict what we can do into the field in the real-time data. So the way this technology is that this technology is affordable, because here the problem is that technologies needed to be covered by all and not only by selected niches of companies or companies from the agro sector. So this technology should be covered by all in the way that we can implement agriculture 4.0 to everyone. And what this technology also allows is that a technical support. And this is really important, because we can get technology, it's true, but we need also to get this technological support to implement correctly and to know exactly what kind of decisions you need to take, and to know how can we take them in a more predictable way. And so this technology, and this is what a little bit were already presented in the talk before. So we get the real-time monitoring data with customized sensors that can be or for soil, plant, or both. So these are designed according to the need of this problem or the farmer, so to answer certain problems. Then we have the remote communication data, and in order to be affordable, we designed, or we are using different protocols already available, because each one also have different approaches and different prices. And so we need, our philosophy is to bring technology affordable to everyone. So all these data from the field are then processing, so through artificial intelligence and based on biophysical models. And what is really important is that this information could be then transformed in an easy way to be interpreted by the end user, in this case the farmers, and also with the correct technical support to take then the action, for example, if this action means irrigate more correctly, or the quantity, I mean. So all this information arrives in a dashboard. So here we are working very hard also with farmers, because here normally we say that our actors are the farmers, because we have a close relationship with them, in the way that we want to design something that will be easier for them and not for us, because we can also complicate then the actions in the field. So these kind of platforms or dashboards, we are step by step listening and taking surveys from different farmers for the way that they can visualize, in the way that it can be simple, and the message that they want to have according to their farm and according to their parcels and also their size. As I told before, so this kind of SOFIs is not only through the application of sensors that could be commercial, that okay, we can use them, but the important thing is that we can also design these sensors and adapt them for the needs. So this is our different projects that we have been developing with different, not only companies from the wine sector, but also from different universities for the R&D. So in the way that we can answer for their problem. So SOFIs can also be implemented. For example, this is very important in terms of the wine industry to analyze the microclimate that is associated with the grape clusters. And so for this, for example, for the controlling the quality of the grapes in the case before the winery. For example, we can analyze different fruitological changes, and this is really important, for example, in the case also for the wine production, for the precision deficit irrigation, or correlate with different annual agronomic data in the way that you can have these models through the neural network analysis to get these predictions according to the needs and according to the needs of these farmings. So this is some of the examples of practical use cases of the application, different application of sensors to answer, or adaptation to answer different different problems, sorry. Another approach, and this is also a practical use case being developing is to estimate the fruit yield for the campaigns. And here can be, for example, this is in the case of fruits, different ones, the nectarines, the prunes, I mean, the apples or the pears. So here the important is listening to farmers for their needs. And so we are developing, this is automated fruit count, in which to estimate also the yield, and through the analysis of drones, the vegetation index analysis, and also to the analysis of the visual approach through the analysis that we can take with different application of cameras applied into the drones. We want to apply a machine learning not only for the fruit yield estimation, but also work, for example, in the lab, automated lab and in situ lab, that we can know already through the sensors the status of these kind of fruits by the using, for example, taking information, for example, our approach. I mean, here is the predictive information for the bricks or other quality indexes that we can get through the images, but this is really important to get what we call the calibration with the laboratories. And so in the end, in the case of the fruit yield estimation, what we are working is also to count the number of fruits. So then the farmer can take early decisions and early estimations. And what we are talking about is early decisions could be not only, for example, to know the quantity, the yield that they have in that year, but also to know during the campaign how the product is developing, and also for the logistics approach, because this is really important when we are talking about logistics, and not only for the transport, but also for the human resources needed to pick these fruits, because the majority of them are manually. This is other project that is being developing with different partners also here in Portugal, not only as an association, but also different parts from the universities, technological partners, and then the sprayer partner. And this is because, as I said before, it's really important to get to produce more using less resources. And this is, for example, part of the application of that inputs needed a selective approaching for this kind of sprayings. And so here, this project, this is a 3 years project that we are developing, wants to create a spraying approach in the way that can be more selective. And for example, we can get a higher efficiency in their application of the AG inputs with a higher yield, but decreasing the waste, for example, and here we can talk also about the water that using and the less also products that we can use. So be more efficient using less. And so for sure, this is through the application of different sensors, not only for meaning the control and monitoring, but then the analysis that we need to know if this spraying is being effective or not. Another part of this project consists in the development of robots, in particular these kind of robots that are needed to pick different products, for example, zucchinis, tomatoes, peppers in the greenhouses, because here in the location that I'm talking from is very important in terms of the greenhouse production. And here also, I think that is a major problem all across Europe and the world, is the human resources to pick the products, and so for the harvesting. And so this is a product that we are developing to specifically for the greenhouses to pick different products, in these particular ones that are more famous here in this region. So as I told before, these are some of the practical uses of different digital solutions, edge ones and their application in the field. But as I told in the beginning of my talk, we can get different digital approaches, but we need also not only to promote this dissemination, but guarantee the adoption of these digital technologies for different targets. Could be the farmers, could be even the schools, because normally we say that the youngs of today will be the workers of tomorrow in different fields. And so we need also to bring this information that digitalization is evolving all days. And so sometimes it's even hard to be aware of everything that is happening in the world, but it's our mission also to bring this information into our targets. And so we are developing different workshops, not only, for example, in terms of the calibration of the spraying equipment, and again here to correct the management, let's say, of the production factors, but also to know and to minimize the application of these age inputs, but also bring these technologies for the schools. And so for different students, the smallers, the biggers, and also the farmers, and developing different events to promote the dissemination and the public awareness about these digital technologies. So I hope that I was on time with my presentation. Once again, I really thank you so much for these opportunities, and thank you so much once again.